Hello and welcome to this video where I'll explain to you step by step how you construct a ray diagram in a convex mirror in order to obtain the position and even the nature of the image. Let's do this by looking at this question where we are given the figure shows an object at some distance from a convex mirror, and at this point, how do I identify just from the diagram that it's a convex mirror? You will observe that it is the reflecting surface curves outwards. It curves outwards. So the position of the object is in this direction. That is how you identify a convex mirror just from the diagram. We are asked, by drawing rays, complete the diagram to identify the position of the image. At this point, we recall the rules for ray diagrams, and the first two are the ones that I'm going to use. If it was a convex mirror, the first rule will go like this. A ray of light which is close to the principal axis, this dotted line is the principal axis, a ray of light which is close to the principal axis and parallel to it is reflected in such a way that it passes through the principal focus. This is the principal focus and this is the mirror. So there is no way an incident ray from the object can pass through the principal focus of a convex mirror. So for a convex mirror, the same law goes like this. A ray of light which is close to the principal axis and parallel to it is reflected in such a way that it appears to come from F. It appears to come from F. And the word appear is very important because here we are going to look at virtual rays. And how do we do that? So we look at the position of the object. This is the object. We are going to draw rays from the head of the object. That is what we always do. We identify the head of the object, and in nearly all questions you'll find that the object is represented by an arrow. I'm going to talk about the orientation of that object later on in the video. So this is the object, this is the head. And we draw a ray of light from the head which is parallel to the principal axis, and this grid helps us actually because we're going to draw a ray like that. We identify this point. We know that this incident ray is going to undergo reflection because mirrors form images by reflection. So in which direction will the reflected ray travel? That is where this point and this point comes in. I'm going to align this point with this point here with the ruler and then draw a ray moving in that direction. That will become the reflected ray because this one was the incident ray. And then later on we are going to see that it is important for us to dot this ray backwards. We are going to see that in the video. Now, for us to see the significance of this dotted ray tells us that the image is formed somewhere between this point and this point, but we do not know exactly where it is formed. It is somewhere around here, whether it is here vertically or here vertically or here vertically, we do not know where it is formed. All we know is that its head is formed somewhere around between this point and this point. And that head will be along this line. That marks the boundary, how high the head can go, that particular line. So, in order to identify the exact position of the head, we need another rule. We apply the second rule for ray diagrams. And for a concave mirror, I'm talking about a concave mirror, and then we talk about the one for the convex. For a concave mirror, that second law goes like this. A ray of light which passes through F, that is the principal focus, is reflected parallel to the principal axis. So again, we know that there is no way this ray can pass through F. No way, because F is behind the mirror, and unless it appears to pass through F. And that is where now we apply that rule to convex mirrors. When we apply that rule to convex mirror, the rule goes like this. A ray of light which appears to pass through F. A ray of light which appears to pass through F. So we align the head of the object with F and then draw a solid ray like that. If we were to continue with it, it will pass through F. So we don't continue beyond that point. So we just dot it to show that it appears to pass through F. That ray will be reflected parallel to the axis. And let's look at the actual diagram that we have already drawn for this in order for you to get the concept. And here it is. So the first ray was this one here, parallel to the principal axis, and then it is reflected in such a way that the reflected ray appears to come from F. Then the second rule is this. A ray of light which appears to pass through F is reflected parallel to the axis. So I get two reflected rays, this one and this one. But the two reflected rays are diverging. They are diverging. So there is no way the two reflected rays can meet because they are diverging. And it is the interception. It is that point where reflected rays meet, where real images are formed. But these two rays are diverging. So what do? We dot them backwards. When we dot rays backwards, we are said to extrapolate the rays. The word is extrapolation. So we are going to dot this reflected ray backwards, like that, as far as possible. And we can see as we dot it backwards, it must pass through F. Then this other one too here, we dot it backwards. And remember how each one of them was obtained. I want to emphasize that this one is an incident ray and this one is a reflected ray. So they must have arrows. In order for you to earn marks in ray diagrams, you must indicate the direction of these rays, because it is important to indicate the direction of movement of light energy. That is what the rays give us. Remember, a ray is that line which shows the movement of light energy. So the incident ray goes like this and then it gets reflected like that. So we've got the two reflected rays which are diverging. So what do? I will dot this one backwards as far as possible, then dot this other one backwards as far as possible, and then where they meet is where the head of the object is formed, is where the image of the head of the object is formed. Remember, when we drew the first ray, we identified this line and we said the head of the image of the head lies somewhere along this line, but we do not know where it is. So we used the third ray to identify, the second ray to identify that particular position, and it is here. And where do we now locate the tail? In most questions, you will find that the tail always lies on the principal axis. But the examiner can fail to do that. In fact, the examiner, like for example, you can see in this question, the examiner has given us an arrow which passes the principal axis. So where on the principal axis, or where above the principal axis or below the principal axis, do we find the tail? So we must repeat these two rays for the tail. This is the tail. And this is where I was talking about the orientation of the object with the principal axis. How is it oriented? if the tail of the object lies on the principal axis, then the tail of the image must also lie on the principal axis. And it will be so easy for you to identify the position of the image, because the moment you identify the head, you just draw a vertical line here, it touches the principal axis, and then you put an arrow there, because that is where the head is formed and the tail will be formed here. It will be so easy, but the examiner can make it a little bit complicated by making the tail not to sit on the principal axis, as in this question. So we are forced to repeat these laws for the tail. So we'll go to the first law here. A ray of light which is initially close to the principal axis and parallel to it is reflected in such a way that it appears to come from F. So again, I identify this point and this point with a ruler, and then I draw the reflected ray like that. But in this diagram, I did not draw that reflected ray, but it's supposed to move like that, so that I can now dot it backwards like that. But remember, it's just this single dotted line that I need in order to identify where the tail is, because the object is vertical. The image will also be vertical. That now brings me to another question. Suppose this examiner had made the image to be a little bit slant like that. What would happen? The object is slant. The image is also going to be slant. And before I go very far, notice that the image that we have identified here is dotted. When we dot the image, it shows that it has been formed by virtual rays, intersection of virtual rays. So the image itself must be virtual. What is a virtual image? A virtual image cannot be picked up on a screen, but a real image can be picked up on a screen. So that is how you identify those two. So how do I identify the tail for an object which is slant like this? So it means this time I will not just apply one ray, because this one will still remain like that. I must get another ray that now starts from here and appears to pass through F. That ray must connect. Let me get another ray. So I'm going to get this ray here that starts from here and appears to pass through F. That is how I will align my ruler, like that. Now that ray must be solid, as far as that ray must be solid all the way up to this point. It must be solid and then dotted like that. So that ray will move like that. And then at this point now, this means this, because it is the application of the second law or the second rule. A ray of light which appears to pass through F will be reflected parallel to the axis. So the moment I get this ray which is going to be reflected this way, I'm going to extrapolate it backwards until they meet somewhere around. They're going to meet somewhere around maybe here. Maybe they're going to meet somewhere around there. Let's do exactly that so that you can see what I'm talking about. This one is so important for you to understand. So I'm now going to draw a reflected ray from that point. That reflected ray must be parallel to the axis. Notice that I've made it parallel to the axis. Now let me extrapolate it backwards. Of course, I know the extrapolated ray must be dotted. But here, because I'm just sliding a solid ray, or a solid line. You will excuse me for that. So you can see that this ray here, which I've extrapolated backwards, it meets this other one here exactly at this point. So the image, the tail of the image, is formed there. That is how you answer a question like that. Now, why am I doing this? I'm doing this in order to emphasize this point. When you are revising, it's important for you to know what the syllabus expects of you. In this part of the syllabus, it expects that the student should be able to construct ray diagrams for a convex mirror to identify the position of the image. So, I've told you the most common question is a question where the object is sitting on the principal axis. But we should bear in mind that this is at the discretion of the examiner. The examiner can make the object sit on the principal axis or fail to sit on the principal axis. It may be floating upwards or below the principal axis. In such a case, if the object is vertical, then it means also the image is going to be vertical, and you just need one more ray for the tail of the object to identify the position of the tail, because you know that since the image is going to be vertical and you've identified that line along which the image is going to be formed, and you know the point where the head of the image is formed, then vertically below that point is where the tail of the image will be formed. But if it is slant, you need two rays coming from the tail, identifying the specific position of the tail. And then you now join the head to the tail. That is what you do. And this is what I do with my videos. In my videos, I don't just show you the answer to a specific question. I go ahead and move around that question to show you how the mind of the examiner thinks and what you can be tricked in. Actually, it is not a trick. It's about testing whether the student has thoroughly understood this particular objective. And how do you know that you have understood a particular question or a particular concept thoroughly? It is by thinking like the examiner. You're supposed to do as many questions as possible pertaining to that particular concept, and each question should be different from the other one. And this is what I do in my videos. I show you how to do that. So if you are new to my channel here, consider subscribing, because there is a ton of information in my channel, and when you go through this channel, you'll definitely learn a lot of concepts. You can even go right ahead and get in contact with me. If you need specific help in specific topics, just get in touch with me and we'll work out a way on how I can be able to guide you through some of the concepts in physics. Otherwise, that is how we would answer a question like that one. I hope to see you in the next video where I look at a different concept.